In the endless reaches of space, hidden in the dark corners of the universe, lies an object of both immense power and profound mystery. These cosmic giants, black holes, are some of the most fascinating and enigmatic entities ever discovered by humankind. With gravitational forces so strong that even light cannot escape their grasp, they challenge our understanding of physics, time, and space itself. But the story of black holes is not just one of destruction. It's a story of growth, evolution, and creation. Of tiny seeds that grow into titanic monsters. These dark forces don't just consume. They shape the very fabric of the universe, influencing the birth, life, and death of galaxies, stars, and potentially even the cosmos itself. The journey of a black hole begins in a way we might least expect. They're not born giants, but rather as faint, almost invisible entities emerging from the collapse of massive stars. Tiny at first, these objects embark on an incredible journey, growing, evolving, and gaining power. From these humble beginnings, black holes grow into some of the most monstrous, awe-inspiring structures in existence. It all starts with the death of a massive star, one much larger than our Sun. For billions of years, these stars burn bright, fueled by nuclear fusion in their cores. But eventually, the fuel runs out, and the star can no longer maintain the delicate balance between the inward pull of gravity and the outward push of radiation. Without that support, the star collapses inward, triggering a supernova. A violent explosion so powerful that it can outshine an entire galaxy for a brief moment. But in some cases, what's left behind is far more remarkable than the explosion itself. A collapsing core, so dense and compact that it forms a singularity, a point of infinite density, surrounded by a boundary known as the event horizon. It's here, at the moment of collapse, that a black hole is born. At first, this new black hole is small, almost undetectable, just a few times the mass of our Sun. But even in its infancy, it possesses a gravitational pull so intense that it can begin altering its surroundings. It is a quiet newborn, but it is already a force to be reckoned with. These newly formed stellar mass black holes might not seem like much at first, small, faint, and often unnoticed. But despite their size, they carry within them the potential to evolve into something far more powerful. These black holes are hungry, driven by an insatiable thirst for mass, stars, gas, and anything that crosses their path. In binary systems, where a black hole exists alongside a companion star, the black hole can begin siphoning material from its companion. This process forms a swirling accretion disk, a disk of hot, spiraling gas that heats up to millions of degrees as it spirals closer to the black hole. The gas becomes a glowing beacon of X-rays, which allow astronomers to detect the presence of the black hole from billions of light years away. But even these stellar mass black holes are just the beginning. They are not the end goal, but rather the stepping stones to something much larger. Supermassive black holes. These seemingly ordinary black holes are the seeds, the quiet beginnings of a cosmic transformation. Far beyond the stellar mass black holes lies an entirely different class of black hole, supermassive black holes. These behemoths lie at the heart of nearly every large galaxy, including our own Milky Way. With masses ranging from millions to billions of times that of the Sun, supermassive black holes are the true giants of the universe. But how do these supermassive black holes form? How do they grow from their modest stellar beginnings into titans that dominate the hearts of galaxies? The answer is elusive, yet fascinating. Some scientists believe that these giants began as smaller black holes in the early universe. Black holes formed by the collapse of massive gas clouds, or even from the merging of smaller black holes. Others propose that primordial black holes, created in the first moments after the Big Bang, might have been the initial seeds from which these supermassive black holes grew. Over time, these early black holes would have begun feeding on their surroundings, devouring gas, stars, and even merging with other black holes. This feeding frenzy, known as accretion, allowed them to grow at incredible speeds, accumulating mass over billions of years. In some cases, these black holes may have grown rapidly through the consumption of vast amounts of gas in the early, dense universe, potentially transforming into supermassive black holes much quicker than we thought possible. But black holes are more than just voracious consumers of matter. They are creators in their own right, shaping the very galaxies they inhabit. At the heart of every large galaxy lies a supermassive black hole, and it is here that the evolution of both the black hole and the galaxy is deeply intertwined. The energy released by a supermassive black hole, particularly through powerful jets of radiation and particles expelled from its accretion disk, has a dramatic effect on its host galaxy. These jets, known as relativistic jets, can extend for millions of light years, stretching across the galaxy like cosmic beams of light. They are so powerful that they can heat the gas around them, preventing it from collapsing and forming new stars. This feedback process, driven by the black hole's intense radiation, can regulate star formation, preventing galaxies from becoming too fertile, and instead pushing them into a stable, long-term state. In this way, black holes don't just consume, they control the life cycle of their galaxies. Black holes, in a sense, serve as cosmic architects, helping to shape the structure and evolution of the galaxies around them. Their influence is as profound as it is mysterious. Despite the central role they play in galactic evolution, the precise mechanisms that drive the growth of supermassive black holes remain a tantalizing puzzle. How do they grow so massive in such a short span of time? One possibility lies in the mergers of smaller black holes, which often occur when galaxies collide. As galaxies come together, so too do their central black holes, eventually merging into a single, more massive entity. These mergers are violent events, emitting gravitational waves, ripples in space-time, that provide us with direct evidence of these cosmic collisions. Another possible mechanism is the steady accretion of gas from the early universe. In the dense, hot environment of the early cosmos, vast clouds of gas may have flowed into these nascent black holes, fueling their rapid growth. Some of the most massive black holes we observe today may have formed in this way, by gobbling up everything in sight during the tumultuous early years of the universe. As black holes grow, their influence continues to expand. But what happens when a black hole becomes too massive? Is there a limit to their size, or can they grow indefinitely, swallowing everything in their path? As a black hole grows, it exerts an even stronger gravitational pull on its surroundings. However, as it becomes more massive, the material around it may become less abundant, and the accretion rate may slow. In some cases, supermassive black holes might reach a point where their growth stagnates, either because they've consumed all the nearby gas or because the energy they release prevents further accretion. While the ultimate fate of supermassive black holes is still uncertain, one thing is clear. They are not just passive objects. They are dynamic, evolving entities that shape the universe around them in ways we are only beginning to understand. And one day, as the universe continues to evolve, even these giants may meet their end, or transform in ways we can't yet imagine. The story of black holes is one that stretches across the entire history of the universe, from the first moments after the Big Bang to the distant future, where black holes may play a role in the ultimate fate of the cosmos. They are not just objects of destruction. They are forces of creation and transformation. Their evolution is tied to the very formation of galaxies, stars, and the cosmic structure we observe today. As we continue to peer deeper into the cosmos, using new technologies and advanced telescopes, we may one day unlock the secrets of these dark giants. How did they form, grow, and shape the universe? And what lies inside the event horizon? A place where the very rules of physics break down.